Okay, good morning. Hope everybody had a good weekend. So we're gonna do just a reminder that your midterm 2 is due today. So a lot of you have already emailed that to me, but if you haven't done that, you have until the end of the day today to email me your midterm 2. Okay, so make sure you do that. Um, all right, and so yeah, midterm 2 due today via email. Okay, so I think we're after the midterms are all submitted. I think we're pretty much caught up on the syllabus. And so if you look here, this is due today. The midterm 2 take home. The extra credit that we did last Wednesday, if you want to do that, that's also due today. And then I think the rest of these things, assuming we don't get behind, um, at this point, I think we're up to schedule. And so these two assignments, which we'll do this week, just like the syllabus, are going to be due next Monday, April 26th. All right, and then so we got this last, we're 2/3 of the way done now, I think. And so we got the other third, and we got the final exam, which is just like another take-home exam. Yeah, and so 2/3 of the way done, and I think we're essentially caught up in the syllabus. And so this is the one we're going to do today, which is going to be due next Monday. And we'll do this one on Wednesday. The next one, 4, 5, and 4, 6, also due on Monday. Okay, so let's go ahead and start this one. So we got a few more exercises in example 14. And then the next chapter we'll get to is example 10, which will be some simulations and some other stuff. Okay. Okay, if you want to open up the example 14, we're going to do 3 exercises. They're relatively short, so we should have plenty of time to do them. And then there's some practice questions if we have time for that. But you can open up example 14.2, 14.3, and 14.4. Okay, and then the first one we'll do is the cost regression 1. You can open up that one. All right, we'll get to this other stuff in a little bit, but let's start with this one, cost regression 1. Okay, so let's go here. Okay, so we're gonna do some different things with regression analysis, and so we're gonna need the data analysis toolbar in Excel. So I'll show you how to load that. We'll load it just like the solver, and so hopefully that works. So we'll get to that at example 14.3. Okay, so we're gonna do some problems here where we're looking at estimating total cost for different products. And so first we're going to start with just a single regression where total cost is a function of the units we produce. And then in the next examples, we're going to add some additional x variables. So there'll be more than one variable in these ones. We're going to have multiple products. And example 14.4, we're going to have multiple plants. So I'm going to show you some different things that you can do in regression analysis when you start adding more than one variable that affects y. So the first one, we've done something similar to this a couple times with the trend line and everything like that. And then example 14.3 and 14.4, a little bit different. You might have done stuff like this in any statistics course or maybe econometrics, but we'll just cover the basics. But this stuff is pretty useful, and I'll show you kind of the highlights here. So let's start um, with example 14.2 and 14.2. All right, so I think this is the description here. All right, so in the previous text, this was example 16.2, but for us, I believe it's 14.2. So this is estimating total cost for a single product. So consider a company that produces a single product. For each of the past 16 months, the company has kept track of the number of units produced, as well as the total cost. These data appear in figure 16.8, or for us, it's 14, whatever it is, in cost regression 1. So what can simple regression tell us about the relationship between the two variables, and how can it be used to predict future production costs? All right, so we have a chart like this on our graph, or on our spreadsheet. Okay, so see this, we have different months. 1 through 16 is what we have data for, and we have how many units this company produced, and then the total cost to produce those units. So we've done this type of stuff before, but based on what's happened in the last 16 months, we're going to estimate a relationship between total cost of units produced. So when we produce a certain number of units, what's the total cost? And then if we expect to produce 400 and 800 units in months 17 and 18, what's our expected total cost? That's what we're doing. So based on what's happened here, we're producing this many units in the next 2 months, and we want to estimate what our total cost will be, so we know what our total cost will be. Okay, so that's all we're doing here. All right, so the first one, probably the shortest one, example 14.2, which is going to be estimating total cost for a single product, so cost regression 1. All right, that's the one we're starting with. So first thing, let's create a scatter plot of units produced versus total cost. All right, so we've done this a bunch of times, but first thing you always want to do if you have just two variables is just look at what the data looks like. So that's what we'll do. All right, so go ahead and just select this area, B1 to C16, all the units produced and all the total costs, all right, that are next to each other. So select B1 to C16, and then insert. Okay, we want to do the scatter, so this one, insert scatter, and then just scatter. All right, so you should be able to get a scatter plot like that, where you have units produced as a function of total cost, like that. Okay, actually, I'll put it down here because we're going to do some stuff up here. All right, so it should look something like this. Let's just make a few labels, and then looks good. So I just want to show which axes. So it should be that total cost is the y-axis, which is correct, and units produced is the x. So we're trying to see when we produce more units, what's our predicted total cost. Okay, so if you click on the chart like this, and if you click on the plus sign, uh, we can uncheck chart title and check axes titles, and we can call this one, this is the y variable total cost. Okay, and this is the x variable, which is units produced. Okay, and so that's enough. We just wanted to see what it is. We're going to do some trend lines in a minute, but remember that if you don't have that little shortcut, the way to get the options on a Mac or something from the top menu is click on the chart. Okay, click on the chart and then go up here to chart design. All right, and then you should see add chart element. Okay, and you can unselect things like the chart title. I chose, you can choose none. And you can select things like the axis title. You can select the primary horizontal and the primary vertical and do it that way. And then just it should put the options up and just type in the x-axis is units produced, and the y-axis is total cost. Right? Okay. All right, so we can see clearly that when we produce more units, total cost goes up, right? Each time we're just looks like on average when we're producing more units, that's to be expected. Total cost goes up. We want to find out how much. All right, so we've done this a bunch of times, but let's do it here. Trend line. Let's add a linear trend line. We'll display the equation. We have not displayed the r squared, which we're going to do now. And I'll tell you what that means because it's kind of important for this step and the next steps, or this uh, example versus the multiple. Okay, so the r squared value, which I'll explain in a second, you might be familiar with if you took any statistics. But if not, it's got a pretty simple interpretation that's pretty useful. And it's an option here in the trend line. So let's add a linear trend line. Let's display the equation. And let's also display the r squared. And then we'll do a little formatting. Okay, click on your chart. Click on the plus sign. Go down to the trend line. Click on the arrow. Click on more options. All right, and you got the options over here in the box, and you want to leave it as linear. And the only thing else you want to do is click down here where it says display equation on chart, and also click display r squared value on chart. So click those two boxes at the bottom for the equation and the r squared, and they should pop up here on your chart. And again, let me do that the other way from the top menu as well. All right, so Mac process to do the trend line, click on the chart, click on chart design, click on add chart element, click on trend line, and click on more trend line options. And that'll take you right to that parameters box again. And in that parameters box, leave it as linear, and then click on display equation on chart, and click on display r squared value on the chart. And it should, either way, it should give you this trend line with this equation and the r squared. So did everyone get uh, the trend line with the equation and also able to get the r squared here? All right, so again, we've done this a bunch of times. The only difference is we displayed the r squared, and so you should have been able just to check that box. If there were any problems trying to get the r squared, let me know. But it should have just been another option to select. So you should see the equation and the r squared. Okay. Now let me just tell you quickly what the r squared is. So the r squared tells you how much of the dependent variable you explained. And so when your dependent variable moves around with different observations, like we have here with total cost, this essentially tells you how much you explained it with the trend line or with the regression equation. And the highest value you can get is 1. The lowest value you can get is 0. And so what this essentially means is we explained about 97% of when total cost changes, this variable units produced explains about 97% of that. So most of the variation, it seems, in total cost is explained by units produced. And in fact, since this number, the interpretation is the percent variation explained in the dependent variable, you can say exactly what that means. So that's on a scale of 0 to 1, we explained about 97%. So if you were interpreting that, you can say this equation explained about 97% of the variation in total cost, right? So that's all that means. That's the amount or percent of the variation you explained in your dependent variable. That's all it means. It has nothing to do with the x variables, only the dependent variable, which in this case is total cost. So that's a pretty high number, and you can see that uh, the line is pretty close to the dots, the observations. So it makes sense that if your observations are close to the line, you explain more of it. So Again, if r squared is 0, you explain nothing. If it's 1, you explain 100%, and we explained here about 97%. Okay. Last part of this step, let's just format the trend line. If you click on it and right click it and click on Format Trend Line Label, and just change the category to number. All right, there you go. So, okay, you got your equation and you got your r squared, and it should look something like that, where you got r squared of 0.97, and the equation should be something like 198.47 times x plus 23,643.26. All right, so we've done that. Step 2, last step here for this one is let's create a new column called estimated TC for estimated total costs, and let's calculate the estimated total cost for each month using the parameters from the trend line, and then let's get our forecasted months just based on how many units we think we're going to produce. All right, so that's all we're doing here. Okay, so let's go right here to column D1. Let's call this estimated TC. All right, and all we're going to do is specify the equation and get the estimated total cost, including um, what we think it to be for months 17 and 18. So just here in D2 equals, I'm typing in this equation, 23 equals 23,643.26 plus parentheses 198.47 times x, and x here is units produced. All right, so note that you got to specify your correct x, which in this case is units produced. So y is a function of x, so total cost is a function of units produced. So I'm typing in this equation down here that we got from the trend line, and just plugging in x. The first x for month 1 is B2. Okay, so you should get something like that. Um, if you want, you can, if you got that equation there, you can grab the bottom right corner and drag it all the way down to row 19, like that. Okay, and there you're getting your estimated total cost for all the months, including, see, well, let's format this first. Okay, so if you did that little step, um, you can select the range, all the estimated TC D2 to D19, and then do Home tab, Format, Format Cell, and you can just change the category to Currency and hit OK. There we go. All right, so see what we did with that simple equation? This is our predicted. All right, so these dots were the observation that occurred. These numbers are what we predicted on the line, and then if we extend the line, or sorry, not if we extend the line, but if we produce 400 units in month 17, that's our expected total cost, and if we produce 800 units in month 18, that's our expected total cost. So based on the analysis we got, these are what we would expect in months 17 and 18, based only on producing these specific. If we produce different units, it's going to change. But these, if we're going to produce this many units in the next 2 months, respectively, then these will be our predicted total costs for months 17 and 18. Okay, so did we get the estimated total cost figures? Did everyone got these numbers that look similar? I'm not sure why everything is 0.26, but I guess that's what it is. Oh, probably because, yeah. Okay. Um, okay, so everyone good on this one? I think we're done with the first one. All right, so this is the example 14.2. You can save this one. All right, and that's gonna go right there. We got two more to do. So you can post your. I think the best way to do multiple files is post the first one and then reply to it and post the second one and the third one. You can make multiple posts, but I think it's a little more efficient to just reply to your post. So you're gonna post 14.2 there. We're done with that one, and we got these two to do still. So 14.2 is done. That goes there. Okay. All right. So I'm gonna close this one. And let me know if you have any questions here on this one. But seems like we're good. And close. Okay. Next one. Okay, go back to the 14.2, 14.3, 14.4 section, and we're going to do the next one, cost regression 2. So open up this file right there. Okay, so we're do example 14.3, which is an estimated total cost for several products. Let me see if I can find the description. There's an optional video on what we're doing now. It's called multiple regression, which just means adding more x variables to that explain the y variable. So here, the only thing that explained y, the only thing that explained total cost was units produced. Now we're going to have multiple types of units that explain it. So if you add more than one x variable to explain your y variable, then you're doing multiple regression. And there's a nice little, I think it's a little bit on the longer side. It's like 20 minutes, but it's a pretty informative video. If you haven't taken statistics or just need a refresher, I'd recommend this one that goes along with this exercise. All right, here we go. Estimating total cost for several products. This for us is example 14.3. And suppose the company in example, the one we just did, now produces three different products, products A, products B, and product C. Companies kept track of the number of units produced for each product and the total cost for the past 15 months. So here's the data in our file, cost regression 2. And the question now, what can multiple regression tell us about the relationship between these variables, and how can multiple regression be used to predict future production costs? So we're not going to do a trend line because we have more than one thing affecting affecting Y. So if you look at the spreadsheet, okay, so this is the month, this is the Y variable, total cost, all right, and then this is like X1, X2, and X3, all right. So we're trying to see how each of these specific units separately affects total cost. So it's going to be likely that each product has a different cost, right? So this one might be more expensive than this one, or vice versa. We want to see that. We want to isolate that effect of each unit on total cost. And you couldn't just do a trend line for this because it's like four-dimensional. So uh, you could look at specific trend lines, but we want to see the combined effect. So because we have more than one trend line, we have more than one x variable. In fact, we have three. We're going to have to do all these together in a different type of multiple regression, which I'm going to show you. So the goal here is to see how this, and this uh, combined affect total cost. So there's three different things that can affect total cost, as opposed to just one that we had the first time. So let's see if we can make sense of this. Okay, so we are on now example 14.3. Okay, so the first thing we're going to do is I'm going to show you how to load data analysis. So we need to use hopefully a feature you have, which is called data analysis. So, okay, so you gotta do this. You gotta load this if you don't have it, which you probably don't. So if you click on the data tab, all right, and so remember how I showed you how to load solver? Over here, what you should have, if you don't see the data analysis feature below it, then you need to load it. And let me show you how to do that. And I know there's we gotta do it two ways, one with Windows and one with Mac. So the goal is to get this data analysis option here. So if you're using Windows, let's start there. All right, so do this, click on the File tab, click on Options, click on Add-ins, and down here where it says Manage Excel Add-ins, click on Go, and assuming you're using the student version or any full version, you should, or you definitely should have the add-in here available, and so you want to add or check the Analysis Toolpack. All right, so if you see Analysis Toolpack, check the box, hit OK, and when you click on the Data tab, you should see the Data Analysis option right here under Solver. Okay, and again, you have to get there the other way of using a Mac, which is, I can't remember how to do it, but so you want to click on what's the like options up here, and then is anyone here using a Mac that remembers how to do it?
Data at the top, and then get external, or yeah.
No, isn't it options or?
Oh no, sorry, it's tools and then Excel add-ins.
Yeah, that's it. Thank you. So if you're doing, if you're using a Mac, up here you should see Tools, and when you click on the Tools drop-down menu, you can go to Excel add-ins, and that'll take you right to that the add-ins box like this. Okay, so on a Mac, when you click on Tools and then Excel add-ins, it should take you right here, or it should pull up this box. And when it pulls up this box, click on the Analysis Toolpack and hit OK. So both those ways should do it. Anybody having problems doing that? So was anyone not able to load the data analysis? Does anyone need me to do it again, or need some help with data analysis? Okay, so everyone has it. Everyone clicks on the data tab and sees data analysis. So look, all of you have it. Abdullah, Christian, Derek, Raymond, two Ryans, Timothy. Everyone has data analysis.
Yeah.
Okay.
Yes.
Okay. Great. All right. So now that we have data analysis, we're gonna use it to do a multiple regression. What is going on here? Okay. So step one is we're going to use data analysis, which we now have available, to estimate a multiple regression with total cost as the dependent variable and units A, B, and C as the three independent or X variables. All right, so that's the goal here. Okay, so what you want to do is go back to we're on the Excel file and just click on the data tab. Okay. And then click on the data analysis button. So open up data analysis and it should take you here. Okay, so when you click on data analysis, you'll see the analysis tools. And the tool we want to use in alphabetical order is regression. Okay, so you should see that. Just scroll down, choose regression, hit OK. And it should take you to this regression box. And we need to specify the Y range and the X range. So the Y range, if you click on this button, you want to choose the total cost range, which is E1 to E16. And hit that button. And the X range, you want to choose all the units A, B, and C at the same time. So if you click on this button and choose B1 to D16, and hit that button. And you also want to click on this box that says labels, so that'll show you the name of the variable when you do the output. Okay, so nothing else needs to be selected, but in this box, make sure your Y range is E1 to E16. Your X range is B1 to D16, and this labels box is checked. So double check that, and that. Okay, so everyone got that? All right, so if you got those Y, X ranges selected and the labels checked, go ahead and hit OK. And what it should do, depending on your options, is it's probably going to pull up, sometimes it puts on the same thing, but most likely it's going to pull up a separate sheet or a separate tab and put the results there. So see how I got a separate sheet, sheet 1, with the summary output. Okay, so we got that? Everybody got the summary output? Yeah.
Yeah.
All right, so let's go ahead and see what this stuff is. And all right, so first thing I think the easiest first thing to do is just to format the numbers a little bit because they're super. There's the ease. So if you click on that triangle up there, right, to select everything, we can format all the numbers to be a little bit easier to read and go ahead. So here's click on that. All right, see how everything is selected, and then Home tab, Format, Format Cells. Let's just change it to number with 2 decimals, and let's also put in the comma. All right, so number, 2 decimals with the comma, and hit OK. And then also, because some of the areas need to be expanded to see the titles, with everything selected, if you want to just click on um, Home tab, Format, and then Auto Fit Column Width. Okay, that should make it so you can see all the titles now. All right, so we did the number formatting and we did the auto fit, so that way that expands the titles that we can see. Okay, so did that work? Yeah, so we got all our numbers formatted to be 2 decimals. With the commas, we can see all our labels there. Okay. Okay. Sorry. Okay, so the things we're gonna interpret, the things we need to talk about here, are the adjusted R squared, which is the same as the R squared interpretation, but you want to use the adjusted one if you're looking at multiple X variables, which we are. So I'm just gonna highlight the numbers we're gonna focus on. B6. Okay. And all the coefficients, which are these ones here. Okay, so everything else has meaningful statistical interpretation, but let's not worry about the other stuff for now. Let's just focus on the adjusted R squared and the coefficients, and that'll be enough for now. The rest of this stuff is important, but we're not going to go too deep dive into statistical um, terms. But if you have any questions on these other things, I can answer them. But for the scope of this class, let's just focus on the adjusted R squared for now and the coefficients. So double check that your adjusted R squared and your coefficients are the same as what I got there. Okay. Now let's see what we can do with this. Okay, so we did part one, and step two is let's see if we can write out our multiple regression equation using the coefficients. All right, so maybe I'll just do it right here. So these coefficients show the separate effect um, of that x variable on y, which is total cost, holding everything else constant. And so to write out the full equation in like a full linear aspect, you can write it out kind of like this. I'll just do it right here. Okay, total cost equals the intercept, which is that. Okay, and then plus this is the coefficient for units A, or the effect of units A on total cost, so 12.80. Oops, times how many units of A we produce, so times units A. All right, and then plus, this is the one for B, 1769, times units B. All right, and then the last one is the one for unit C, which is this one, 15.23. Okay, so I just want you to know how to specify the equation based on the coefficients you got. And so what we're looking at here is this is the effect of producing one unit of A on total cost. So essentially what that 12.80 means, which we'll interpret in a minute, is basically on average, every time you produce a unit of product A, the cost of that is $12.80. And essentially the average cost of one unit of B is $17.69, and the average cost of a unit of C is $15.23. So you can see that the specific products, so B would be the most costly on average, C would be the second most costly, and A is the cheapest. All right, and so this is uh, basically that's the effect of this x variable, units A, on total cost, holding everything else constant. Okay, and to write out the full equation, you just do it like that, where you got the y variable total cost is a function of the intercept plus the coefficient for one of the x's, units A times units A, plus x2, which is 17.69 times units B, and plus 15.23 times units C. Okay, so there's your equation there. All right, and you can also interpret um, the adjusted R squared and the coefficients. So I kind of just interpreted these, but let me write it out so we have it on the spreadsheet. So you can interpret the adjusted R squared, remember, is the percent variation of the dependent variable that you explained. In this case, the dependent variable is total cost. So let's explain the adjusted R squared, and then let's explain the coefficients, and then we'll get the estimated total cost for the 2 months that we want to predict. Okay. Here's actually I'll do it up here. So here's the adjusted R squared. All right, and so what that means is this is a scale of 0 to 1. How much of the variation we explained in the dependent variable, and so it's here it's 93%, right? So 0.93 on a scale of 0 to 1 is 93%. Okay, so I can just type that in there. Say like this. Oops. All right, so something like that. So right next to the adjust r squared, you can see the 0.93, which means essentially that approximately 93% of the variation in total cost, the y variable, is explained by this multiple regression. So pretty good. All right, so that's how you would interpret that adjust r squared, which I put right there. Okay, and then we can also interpret the coefficients, which I'll do now. So I'm going to kind of copy and paste them so I can interpret them right next to each other. All right, and so if you want to, you can kind of take this select A16 to B20, copy it, Control C, and maybe go down right there to A24 and paste it, Control V. Okay, and I'll just interpret the coefficients right next to them. I made this. All right, so there's our equation. Okay, and if you want, so don't worry about interpreting the intercept. That's just kind of where the relationship starts. But remember, I explained that the holding everything else constant, this is the effect of producing one unit of this x variable, or changing x by one unit on the dependent variable individually. So basically, if you change units a by one unit, this is the effect on total cost, which means in this case, if you produce one more unit, this is the total cost to produce it. So what we can say about this number here is yeah, right. So on average, producing one unit of product A costs $12.80. So that's the average cost, or the average effect on y of changing x by one unit. X is just units A, so we produce another unit A. That's the expected cost for us. Okay. Same thing, except we have different numbers for units B. So this is the average cost of producing one unit of B. This is the average cost of producing one unit of C. And I'll just go ahead and put those there. Okay, so producing a unit of A costs about $12.80. On average, producing a unit of B costs $17.69. And producing a unit of C costs about $15.23. And remember, all of these essentially are the isolated effect of just looking at this variable and its specific effect on y. And so you're when you're interpreting these, you're essentially holding everything else constant. And so that's kind of the clause you would always write, is each of these is made assuming that everything else is constant, because if you change something, then this number might change. So just kind of put, after you interpret all your coefficients, you can just make a little clause saying, all right, so holding everything else constant, and that way that covers you if you're so if you make a claim and something else changes, then if something else changes, your claim changes. So this is what this interpretation means, is this is only the interpretation for this data um, for units A on total cost, holding everything else constant. So you gotta make sure that you're making your claim given the parameters. So we're not making any claims yet about any other months or any other units. It's just how this affects this given the current data, holding everything else constant. Okay, so we got all the interpretations. Everyone clear on what the r squared, adjust r squared, and how you interpret the coefficients there? All right, last thing for example 4.3 is let's estimate, let's predict our total costs using the equation we got, and then let's get our forecast for months 16 and 17. So what we want to do is we need essentially to put this, specify this equation. All right, so let's go back to the data tab and let's call F1 estimated TC. All right, and we want just to put in this equation essentially. Um, so what if I'm just gonna try to make a shortcut. So if you typed in the equation, actually, I want to put this into that. This is our equation. So let me see if I can do this. If you typed in the equation, you can copy and paste it, and then just kind of format it a bit. If not, you can just type it in. But I'm going to try copying it. So if you wrote this here in A22, you can copy it, Control C, and you can paste it right here in F2, Control V. All right, and so let me just make it so it's okay. So this is what it should say. So if you don't worry about if you didn't copy and paste it, but I'm just trying to save myself so I don't have to go back and forth and look at the numbers. So what it should say is equals 20,000 261.27 plus 12.80 times units A, and units A here is uh, B2, right? There we go. And then plus 17.69 times units B, and units B is C2. And last argument for for unit C, $15.23 times unit C, which is D2. So this is what it should look like. All right, so in column F, this should be your equation, equals 20, 261.27 plus, in parentheses, 12.80 times B2, and then plus, in parentheses, 17.69 times C2, and then plus, in parentheses, 15.23 times D2. All right, so I just took the general equation and tried to apply it to the specific x's. So if you did it copy and paste wise, make sure it looks like this, or it might have been easier just to type it in, but I didn't want to go back and forth and look at the coefficients. But this is your equation. It should give you about 57,289.03. This is the for month one. Did we get that?
Yeah.
Yeah. Okay. Okay, and if we got that, we know what we're doing here. Just take that, click on F2, grab the bottom right corner and drag it all the way down to row 18 like that. And you should get these numbers. Only thing I'll do here is format them to be currency, which we know is just home tab. Format drop down, format cells. You can change it to currency. And you hit OK. There we go. So based on the number of units we produced in each month, these would be the estimated total costs given the historical data. And then what we did here is based on the equation we got, this one, if we apply that equation, right, if we apply that, each unit A costs this much, each unit B costs this much, and each unit C costs this much on average, then we can expect that if we produce this many units of A, B, and C in month 17, that's our total cost prediction. And if we do produce this many units of A, B, and C in month 17, that's what we think total cost is. So we took our historical data, this part, we estimated how much each unit of A, B, and C costs on average and how that affects total costs. And then if we think we're going to produce this much of each of the different types of products, we can use that relationship, and these would be our estimated total costs. So double check those two numbers there that we got in the 45 and 44,000-ish for month 16 and 17. Okay, so did we get that?
Yeah.
All right. Okay. We're done with this one. We got one more to do. So if you got the summary output on a separate tab, and you got the data with the predictions here, you can go ahead and save this one. And that's also going to go right there. Okay, so if you already posted your 4.2, just reply to it, and you can post 4.3. And now let's finish the examples and let's do example 14.4. Okay, so last one for this group is cost regression 3. So go to the same section, 14.2, 3, and 4, and now open up cost regression 3. Actually, let me close this one first. All right, so we're done with this one. You can close that, save it, close it, post it. Okay, last one is cost regression 3. All right, so this one, we're going to look at how total costs might vary at different locations. Okay, so we're going to use a concept here called dummy variables or binary variables. You probably heard the term binary a lot, and this is kind of what we're doing here. So we're about to do this one. Example 14.4, which is estimating production costs at 3 company plants. So use cost regression 3. There's an optional video for explaining dummy variables or binary variables, which is kind of helpful. So if you haven't used this concept before, you can take a look at that video. And let me find the description for this last one. We got it. Here we go. Estimating production costs at 3 company plants. So suppose the company, in example, produces a single product at 3 different manufacturing plants. So now we have one product again, but we have 3 different locations. Now it's possible and likely that the cost varies, right? There's different costs at different locations. So as in that example, the company wants to regress total cost on units produced, but it suspects that the relationship between these variables might differ across plants. So it has monthly data from the past 16 months for each of the plants. All right, and that's in cost regression 3, which we're about to look at. And so how can the company use dummy variables or binary variables to estimate the relationship between total cost and units produced for 3 plants simultaneously? So that's what we're doing here. Is the cost different at different locations? It's probably going to be, or else this wouldn't be a very good exercise. But okay, so cost regression 3 looks like this. Okay, so see what we got here is we got a big grouping of there's different months and there's different plants. Now you can see that in month 1 we produced some different units at plants 1, 2, and 3, and so on. So each month we have 3 different plants to look at. All right, so scroll through all, and you can see that not only do we have the different time observations, but we also have the different plants. So our goal here is to see does the average cost to produce a unit change at each plant. All right, so that's what we're doing here. So we're going to have like if statements, binary statements saying like if this occurred at plant 1, put a 1 there. If not, it's a 0. But we got to put the location somewhere. So step 1, let's add 3 new ranges in columns E through G called plant 1, plant 2, and plant 3. All right, so let's do that first. So here's your spreadsheet. So in E1, let's call this plant 1. Okay, in F1, let's call this plant 2. And in G1, let's call this plant 3. Okay, so we're going to write an if statement to tell Excel if this occurred at plant 1, then put a 1 in there. Otherwise, put in a 0, and we'll do the same logic for plants 2 and 3. So you'll see that the plant's going to have a 1 in its location and a 0 in the 2 places it did not occur. So that's the concept of binary variables. Either it happened there or it didn't. So 1 or 0. Okay, so let's put in this equation in E2, and we'll modify it based on what it should be. So let's start with this. So put that equation right there in E2, which is right there. So equals if, so the if function, B2. So if B2 equals 1, comma, 1, comma, 0, and then parentheses. So see what we're doing? We're saying if the specific plant is 1, put a 1 in this cell. If not, put a 0. So if that's a 1, put a 1. Otherwise, put a 0. So it should say equals if parentheses, B2 equals 1, comma 1, comma 0, close parentheses. So because it is a 1, it's going to be a 1, but if it's 2 or 3, it's going to be a 0. So if that's a 1, put a 1 here for our observation. If not, put a 0. So enter. Okay. And then let's go ahead and write the function for plant 2 and plant 3, and then we can copy them all down. So this one should say f2 equals if b2 equals 2, comma 1, comma 0. Okay, so if equals if, parentheses, b2 equals 2, comma 1, comma 0. So if this is plant 2, put a 1 here, otherwise put a 0, and it should give you a 0 now because obviously we're at plant 1. And then last one for plant 3, so same thing except we'll say if this is a 3, put a 1, otherwise put a 0. So in G2 equals if B2 equals 3, comma 1, comma 0. Okay? So equals if, parentheses, B2 equals 3, comma 1, comma 0. So if this occurred at plant 3, put a 1. If not, put a 0, and you should get a 0 now because the current B2 is plant 1. All right, so double check these formulas because we're going to apply them down all the columns. So this one should be equals if B2 equals 1, comma 1, comma 0. This one should be if B2 equals 2, comma 1, comma 0. And this one should be equals if B2 equals 3, comma 1, comma 0. Okay, select those cells, select E2 to G2, and I think we can just, you got those selected, double click. All right, so with that selected, double click the bottom right corner like that, and that should apply your statement for all the plants. And you should see if you go through, if it occurred at plant 1, you got a 1 here. If it occurred at plant 2, you got a 1 here, and if it occurred at plant 3, you got a 1 here. So each should have 1 and 2 zeros depending on where it occurred. So see if you go through, you can see if it occurred at plant 3, you get a 1 in plant 3. If it occurred at plant 2, you get a 1 in plant 2 based on the statement you wrote. Excel was able to apply that logic for all the plants. Okay. All right. So did that work? We got all the plants lined up there. Okay. Now let's set up the range to do a multiple regression. So what we're going to do is use multiple regression where we have total cost as the dependent variable, or the y variable again, and then units produced plant 2 and plant 3 as the independent variable. So you can see here that we're specifically not going to include plant 1 because if we included it, we'd be kind of double counting. So the way we set it up with binaries, if the observation for plant 2 and plant 3 are both zeros, then that automatically means we're at plant 1. So you always want to specify if you're using binaries or dummy variables, one less than you currently have interpreting, because when that's 0 and that's 0, we're automatically at plant 1. So if you put in plant 1, we'd have it wouldn't make any sense, or there'd be some problems because you have a fourth option. So we're not going to throw in plant 1, but plant 1 is when this and this are 0. So when we're at plant 1, when we're at plant 2, this will be a 1. When we're at plant 3, this will be a 1. When we're at plant 1, they'll both be zeros. So that's kind of so basically that's how it works here is we're intentionally not putting in plant 2, plant 1 because when these two are 0, that is plant 1. Okay. What I want to do is put the range over here, so we can do total cost, units produced, plant 2 and plant 3 all together. So I think the best thing to do is to copy and paste the values over here, and so we can select these here because you want to be able to select um, the x variables adjacently. So let's first copy the y variable here. So if you select the D column, all right, just click on the D like that and copy it, Control C. And that, all right, then if you go over here to the I column, and you can paste it. Click on that and Control V to paste. All right, so there's your total cost. And then I want to copy and paste units produced and then plant 2 and plant 3. So for units produced, click the C column, copy it, Control C. And you can go over here, click on the J column and paste it, Control V. Okay, and now these ones, we want to paste only the values. And so if you click on F and G, okay, copy them, right? So select the whole F and the whole G column, copy them, Control C. All right, and then choose the K and the L, but make sure you do it this way. Click on the Paste menu under Home tab. Here's Paste. And there should be an option called Paste Values. Right there, see that? The paste values 1, 2, 3. Okay, and that's going to paste the values, but not the formulas. So see how you got the same zeros and ones, but they're just the actual number, not the formula. Okay, so if that worked, we got total cost here. In the I column, we got units produced here in the J column, and we have plants 2 and 3 in K and L, but we only have the values. So see how it's just zeros and ones, not the formulas we set up. So we did the setup over here, but we just want the values here. Okay, so everybody got this range set up here? Okay. All right, so what we're going to do is we're going to estimate a multiple regression using data analysis where total cost is the dependent variable and units produced, plant 2 and plant 3 are the 3 independent variables. So we set it up nicely so we can select the total cost and we can select the 3 x variables. So go ahead and so we got this here, this here, this here, and this here. All right, and data tab. Um, data analysis. Okay, and you want to do regression again, so scroll down to regression under data analysis, analysis tools. Choose regression, hit OK. All right, so same idea. We're going to select the Y range, hit that button. The Y range is I1 to I49. Okay, hit that. And then the X range is all that, J1 to L49. That, and then hit the labels button. Okay, so Y range is I1 to I49. X range is J1 to J49, and make sure that labels box is checked, and so that way when you do the output, it'll tell you what the variables are. Okay, so we got that specified, and hit OK. And again, we should get a separate sheet sheet 1 with the summary output. Okay, and so I'll do the formatting again, and then we'll interpret this what this means. So click on, if you want to click on that triangle to select the whole sheet, and we can do Home tab, Format, Format Cells, Number with the 2 decimals, and check the box for the comma sign. Hit OK. And also, it's nice to do this Home tab with everything selected, Format, and then Auto Fit Column Width. There we go. Okay, so again, we're just going to interpret the adjust R squared, cell B6, and the coefficients, which are B17 to B20. All right, so everything else don't worry about, but again, double check that you got these numbers similar to mine for the highlighted adjust R squared and the coefficients. Okay, so everybody got these same numbers. Um, okay, so last thing here is let's just interpret what we got, and then we're done with this one. So let's write out our multiple regression equation. Let's interpret the adjust R squared, and then let's interpret the coefficients. All right, so everything's similar, except it's a little bit different with the binaries because the binaries are in basically explain what happens in comparison to the one that wasn't included, which is plant 1. So let's write the equation out. Let's do the adjusted R squared, and then let's interpret the coefficients specifically. All right, so I'm going to put the equation down here again. Again, this is how total cost is affected by these variables. So total cost equals the intercept okay, plus the coefficient for units produced all right, and then plus the coefficient for plant 2, which is that. Okay, and then minus, we got a minus sign here. The coefficient for plant 3. Okay, so there's our equation, and I just all I did there was write out the equation based on these coefficients. All right, so this is the equation we're specifying, and these are the specific coefficients. So total cost is equal to the intercept, which is 22,851.94 plus the coefficient for units produced, 204.15 times units produced, plus the coefficient for plant 2, 12,971.97 times plant 2, minus that negative coefficient for plant 3, which is 15,045.29 times plant 3. Okay, so see how we're kind of putting in the coefficients to get the estimated effect of that specific variable on the y variable, which is total cost. Okay, so we can interpret the adjusted R squared just like last time. So this is the percent of variation that's explained in the dependent variable. So this would just mean that we explained about 99%. So okay, so approximately 99% of the variation in total cost, which is the y variable, is explained by this multiple regression. All right, so that's the interpretation of that. And the last thing is I want to interpret the coefficients. And let's make sure we understand what the how you interpret the binaries of the dummy variables, which in this case are plants 2 and plant 3. So let me copy and paste this range down here, and then we'll interpret these specific coefficients. So copy this A16 to B20 and click on A24 and paste it. Control V. All right, and don't worry about interpreting the intercept. That's just where the uh, relationship starts. But let's interpret these things. So units produced. All right, so this is the effect of, again, changing this by 1 unit. So basically, each time we produce another unit, this is the total cost, or the increase in total cost. So okay, so that's the effect there. On average, it costs $204.15, the coefficient to produce 1 unit. All right, so this is the effect on total cost. And so uh, if this goes up by 1, then that means it costs about this much to produce 1 unit. Now these ones are the effect on total cost um, compared to plant 1. So let me write the interpretation for this one, because this is how much higher total cost is compared to plant 1, because plant 1 was the one that was emitted. So here's our equation. And so when that's 0 and that's 0, that means we default to plant 1, and the plant 1 um, intercept would just be this 22,000 intercept. All right, so here we kind of do have an interpretation of the intercept, because that's the default to plant 1. And so basically what we're saying here is that um, total cost is this much higher at plant 2 compared to plant 1, and total cost is this much lower at plant 3 compared to plant 1. So how you interpret that specific coefficient is like this. Okay, so I think that's how we'd say that. So total cost is 12,971.97. So the coefficient, so total cost is 9,971.97 higher on average at plant 2, and that's only compared to plant 1. So based on the initial intercept, All right, this is the added cost on average of producing at plant 2, and this is saying that plant 3 is cheaper. So plant 1's in the middle, it costs this much more on average just to be producing at plant 2, and this much more on average just to be producing at plant 3. So we do the same thing with this coefficient. The only difference is this is the lower cost at plant 3 compared to plant 1. So this one means total cost is 15. Okay, so I think that's how I'd want to say that. Is total cost is $15,045.20 lower on average at plant 3 compared to plant 1. Yeah. Okay. So again, just so we see what's going on here. Um, when we're not at plant 2 or plant 3, those are zeros, and so this will be the average starting cost, and this is the additional cost, right? On average at producing at plant 2. Right? So this is how much you'd expect total cost to be higher just by being at plant 2, and this is the lower cost. Plant 3 is the cheapest of producing at plant 3. So the binary variables are always like an if statement saying this is the added, uh, or this is the difference producing here, or being at this location, or being in this category compared to the one that was not included, which in this case is plant 1. So this is the added cost at plant 2. This is the lower cost at plant 3, and again, you'd have to say, okay, so these statements are only looking at this specific effect on the y variable and holding everything else constant, and yeah, only in this specific data set. Okay. All right, so I think we're almost done with this last one. Everyone got all this for the cost regression 3. All right, so we got the summary output and the equation, the interpretation of the r squared, and then you see kind of how you interpret.
Professor,
Yes.
sorry, I just noticed this. My numbers are all off actually for after I did the regression. Do you
Okay.
mind if I like post?
Yeah, I'll take a look at it. So let me see. I think yeah, we're not going to have time for the practice questions. So if you've got this one completed, example 14.4, then I think that's about it. So if you got this one done, go ahead and save it and post it here. Okay, so we did example 14.2, 14.3, and 14.4, which were cost regression 1, cost regression 2, and cost regression 3. All right, so those are done. Those go there. Okay, so if you're done with those, I think that's what I had planned for today. If you have any problems with it, go ahead and post it, and I got some time to look at it. So uh, if you're done, you can go ahead and post yours and sign off. If you need me to look at it, just post it here, and I'll look at it right now. So I'll look at the ones if you have questions, or if you're all good to go, then thank you for joining, and I'll see you on Wednesday. So, and whoever who's going to post theirs right now?
Thank you, Professor.
Yeah, thank you.
I needed
Oh yeah, okay.
on my
Okay. So this is Raymond. Oh, I think you might have just posted the original one, because this is just the.
Wait, sorry.
Okay. Ryan, do you need me to look at yours?
I'm just gonna post it right now. Thank you.
Oh, you're okay. You're good. Oh, okay.
I reposted it.
Oh, so it looks like something went wrong with the specifying the plants here. So let's fix that. So I think that's got to be the issue. And then, all right. So let's see what happened here. So this one looks right. Oh, this one isn't. Okay. So you got to write. Let's write the equation here. So um, let's delete all this stuff. Okay. So I think the one for plant one is correct. Uh, yeah, but let's do the one for plant two. So delete the stuff you have there, and then in F2, Raymond, let's go ahead and write this equation equals if B2 equals 2. All right, so that's your equation. And F2 equals if, in parentheses, B2 equals 2, comma 1, comma 0. Okay, so write that one in there. Equals if, parentheses, B2 equals 2, comma 1, comma 0. Yeah,
Yeah, got it.
answer. And then let's go ahead and just copy that one down. So double click the bottom right corner of F2 like that. And that should do the one for plant 2.
Okay.
And then let's do the one for plant 3. So in G2, it's equals if B2 equals 3, comma 1, comma 0. So equals if, in parentheses, B2 equals 3, comma 1, comma 0. So like that.
Okay.
Okay. Then let's apply that one now. So click on that cell, double click the bottom right corner, and that looks right. So you got the zeros and the ones. And then what you want to do is recopy them. Looks like you did this part fine and this part fine. But let's copy and paste plant 2 and plant 3 again to make it look like these. And so maybe just click on K and L over here and hit the delete button on your keyboard. Get rid of that. Let's just redo it. All right, so you got that deleted, and then click on the F and the G, and then copy it, Control C. And let's go over here to K and L, select that. And remember, you want to do under Home tab, the paste menu, and you want to paste the values. You see that?
Oh, okay. Mhm.
Okay, did that work? All right, so you got, see how just double check that you just got the ones and the zeros, no formulas, and then let's just redo your equation. So let's go to, let's see. Well, you can leave that other one. So let's click on data.
Actually, when I pasted it, it's just all zeros and no ones
Hmm.
for some reason.
What about over here? Are these zeros and ones?
Yeah.
Okay, so let's try it again. All right, so maybe hit the back thing so it's gone. Okay, so you want to select F and the G again, and then copy it, Control C, and over here click on the K and the L range. All right, and then when you want to do, see how under Home tab you see the paste menu. Open that
Yeah.
menu and see. Do you see the option for paste the values? There's like that 1, 2, 3 button.
Yeah.
Okay, click on that. Did that work?
Oh, okay. Yeah.
Okay, all right. So we got what we need, and then let's redo the regression equation. So got that there, got this, this, and this, and this. Okay, and you got the ones and the zeros here, and you want to do data tab, data analysis, and regression again, and hit OK. And all we're going to do is specify what we did last time, which should work now, I think. So Y range, looks like you got that, right? It's already defaulted to I1 to I49, so right, so leave that. And X range should be J, is that right? J1 to, let's see, J1 to L49. I think you already have it, yeah. So I think it's all right from before. So you had the ranges correct, just the variables were messed up. So
Oh, okay.
if that says I1 to I49 and that says J1 to L49, and that labels box is clicked, you can just do it again, hit OK, and you probably get a separate sheet with did that do it? So I think that looks right on mine.
Yep. Yeah. Okay. Yeah. Yeah, that did it.
Okay, so there's your, yeah, so that's right. And all you gotta do now is just write in the, interpretations, and that's it.
Okay. Cool. All right. Thank you.
Okay, so you're good to go for the rest of it?
Yep.
Okay, perfect.
All right. Thank
All right, thank you. I'll see you Wednesday.
See you, Professor.